Hey guys, in this video I'm going to go through two examples of how to solve for x given initial equations. Now this is a topic that's covered in Year 11 Maths Methods, but at times it has come up in the Year 12 Exam 1. So it's something you want to know in case you get asked it, and it can potentially be some easy marks for you. So looking at part A, we've got 3 to the 2x minus 10 times 3 to the x plus 9 is equal to 0. Note that we have 3 to the 2x and then a 3 raised by the power of x. Using the basic index laws, we can rewrite this as 3x raised to the power of 2 minus 10 times 3 to the x plus 9 is equal to 0. From here, what we need to do is change this equation into a quadratic form by using a substitution for 3 to the x. And so if we let a equal 3 to the x, then we can rewrite this as a squared minus 10 times a plus 9 is equal to 0. Now we have a simple quadratic to solve. To do this, we factorize, which is going to be a minus 1 times a minus 9 is equal to 0. And solving for a, we're going to get a is equal to 1 or a is equal to 9. Now we need to substitute back to solve for x. And so if a is equal to 1, then this means that 3 to the x has to equal 1, or if a is equal to 9, then 3 to the x has to equal 9. Any number raised to the power of 0 is going to equal 1, and so 3 raised to the power of 0 is going to equal 1, which means that x must equal 0. Or we've got 3 to the x is equal to 9, which we can write as 3 squared. And now equating the powers, x is equal to 2. And so for part A, we've got x is equal to 0 or x can equal to 2. Part B, 25 to the x minus 5 to the x minus 6 is equal to 0. And so just like before, we need to reduce this to a simple quadratic form. But first, let's rewrite this as 5 squared raised to the power of x minus 5 to the x minus 6 is equal to 0. Now using the index laws, 5 squared raised to the power of x is the same as 5 raised to the power of 2x, which is the same as 5 to the x squared. And so we can rewrite this as 5 to the x all squared minus 5 to the x minus 6 is equal to 0. And now we can let a equal 5 to the x, and so we're going to get a squared minus a minus 6 is equal to 0. And factorizing this, we're going to get a minus 3, a plus 2 is equal to 0. Solving for a is equal to 3, or a is going to be minus 2. And now we need to substitute back to solve for x. And so therefore, if a is equal to 3, this means that 5 to the x is equal to 3, or if a is equal to minus 2, 5 to the x is equal to minus 2. Any number raised to the power of x will always be a positive number, meaning that it's going to be larger than 0. And so we can automatically reject 5 to the x is equal to minus 2, as there's going to be no solutions for x. And so we only need to solve 5 to the x is equal to 3. To solve this, we don't have the same base, and so what we need to do is take the log of both sides. And so we need to take the log of base 5 of both sides. And so we're going to take log base of 5 to the x, and this is going to equal log base 5 of 3. Rewriting this, this is the same as x times log base of 5 is equal to log base of 5 of 3. Log base of 5 is equal to 1, and so therefore x is equal to log base 5 of 3. And so for part B, x has only one solution. X is equal to log base 5 of 3. Now that you know how to answer these types of questions, you can try exam questions related to this topic. Log into the Maths Methods Club and from the main topic select Algebra. And then select Logs and Exponentials. Group the questions by Tech Free and see if you can answer 2015 Exam 1 Question 7, the 2014 Exam 1 Question 4, and the 2013 Exam 1 Question 5. And that's it for this video. I hope it was helpful. Good luck, and I'll see you guys in the next video.